Hi, this video will show you how to perform thermal simulations in Glass Advisor. If you're watching this, it means that you are already familiar with the app and you know how to perform a glass simulation under standard conditions. In case you're missing one of those, check the other videos first. Thermal simulation is used when simulating shading devices, but may be used also for glass-only compositions, as the one we have in front of us. The reason why we call them like that is because, differently from the standard simulation that basically gives a theoretical result to be published on datasheets, thermal simulations have actual boundary conditions. And as an output, they give all results of a standard simulation plus the temperatures reached by each element of the glass composition. So they can be used to estimate thermal comfort, maximum temperatures reached by elements, and thermal stress. In order to perform a thermal simulation, simply click on the red button. You will find different options offered. Those are different boundary conditions offered by different norms. So let's talk about them. The first one we find are the reference conditions. Those are the conditions according to the European norm and are consistent with the standard simulation. But please note that in any case, the result might be different from a standard glass calculation. It should be used for solar factor calculations during winter, but also for product comparison in case of shading devices. More about shading devices simulation can be seen in another video. The second option are summer conditions. Those are conditions according to the European norm and represent a warmer situation with a bit more sun to be used to estimate solar factor during summer period. Please note that it might lead to very different results than standard glass simulation, especially for thermal transmittance or U-value calculations. Then you can find two boundary conditions according to an FRC standard, which means this should be used for North American market and a few other countries. An FRC standard don't change just boundary conditions, but also the calculation method is very different, even if this complexity is directly managed by Glass Advisor. NFRC winter should be used for thermal transmittance, when NFRC summer should be used instead for solar factor calculations, or how they call it, solar heat gain coefficient. Now let's perform a simulation with reference conditions. Let's click on it. The first thing that you notice is that on the general information box, we can find also the values of the boundary conditions, which are not present for the standard glass simulation. So we can see an external air temperature, an internal air temperature, convection coefficients, and even an irradiance. All other results are basically very similar to the standard glass simulation, even if the number might change a little bit. The huge difference is that at the end of results, we don't find the spectral values anymore, but we find the element's temperature from the outside to the inside. In this case, external air temperature defined by norm is 5 degrees. Element 1, which is the external glass, have a 7.4 degrees temperature. Element 2, which is the internal glass, has a 22.1 temperature. And the internal air temperature is 20 degrees. As you can see, they are all winter-like temperature, even if this is a mild winter situation. Should we want to find summer results and temperatures, let's just click on the second simulation option, summer condition. As you can see, the boundary conditions become slightly warmer with 25 degrees external and internal temperature and a little bit more irradiance. In this case, values can be much more different from the standard glass simulation, so be very careful when considering them. If we scroll to the end, we will see that the temperatures that come up are more summer-like, even if it's a mild summer condition, not a peak one. So we have an external 25 degrees, an external glass with 29 degrees, an internal glass with 33 degrees, and an internal air temperature of 25. Those results have been obtained with quite mild summer-like conditions. If you want to know a little bit more about simulating with more realistic boundary conditions, which are based on weather historical data analysis, look at the video where we explain one of the features that we are mostly proud about: thermal simulations with weather-based data. In short, thermal simulation lets you obtain temperature of glass and perform glass plus shading simulations. But be aware that results might differ from standard glass simulation, so don't get surprised if you get a different thermal transmittance, for example. Thanks for watching and enjoy your simulations.